Okay, here are just a few extra quick tips for lesson 10.2 when we're looking at similar figures. So you will want to review the key concepts and example slides in the actual lesson, but just as a quick review, that this symbol here means is similar to. So when we have this statement here, we read it, triangle ABC is similar to triangle NOP. And when we say similar, we mean that they are the same shape, but not the same size. Their size is proportional to each other, but they're not equal. So it's different than congruent, where congruent is same size, same shape. Similar means same shape, but proportional sizes. So what we're looking at is finding the sequence of rotations, reflections, translations, and dilations that will transform one shape into a similar figure. So let's look at this example here, and I'll show you what we found helpful in class today. So if we're given triangle ABC, and we know that it's similar to triangle NOP, first of all, the order of the letters matters, the way we name these triangles, because this means that point A corresponds to point N, because those are listed first. Point B corresponds to point O, because those are listed second. And point C corresponds to point P, because those are listed third. And that helps us determine what kind of transformation this is. So we can determine whether this was a translation or a rotation or a reflection. So since I can see that A slid up and over in the same way that B slid up and over, and C appears to slide up and over, all of these points are oriented in the same way, right? So A and N are on the left, O and B are on the bottom in the middle, and P and C are on the right-hand side. So that lets me know that this is a translation. So when we describe the sequence of rigid motion followed by dilation with center 0, 0 that maps ABC to NOP, then we can start by saying the first step in the sequence is to translate or slide this triangle. So now I need to determine how many units I'm going to slide it. So if I want to slide this so that I can then dilate it from the origin, then I need B to move up to the origin. So I'm going to translate up 1, 2, 3, 4 units. And then I need to translate 2 units to the right. That's going to be my first step. So let's map this out. Let's draw that translation. So if I move up 4 and over 2, then point B is now going to be here, and it's going to be the same point as point O, which is at the origin. A, so let's label this also B prime. Okay, A is going to move up 4, 1, 2, 3, 4, and over 2. So A prime will move here, and C prime is going to move up 1, 2, 3, 4, and over 2, so that now I have this triangle. And now I can see that I have triangle A prime, B prime, C prime, and it's bigger than triangle NOP. So my dilation is going to have a scale factor that's less than 1. So what we found most helpful with identifying our scale factor is to list our points. I'm trying to take A prime, which is at -2, +4, and it's going to map to point N, which point N is at -1, +2. Okay, then B prime is going to map to O, so nothing changes here because I'm dilating from this point. And then C prime, which is at 4, 0, is going to map to P, which is over 2, and up 0. So what I'm looking at with these coordinates is, okay, how do I turn a -2 into a -1, and how do I turn a 4 into a 2? Now remember, I'm using a scale factor. Factor means multiply. And I know that I need to turn a -2 into a -1. So I need to think about what I'm going to multiply by to create that change. Well, I know that -1 is half of -2. So let's see if multiplying by a scale factor of 1/2 will work for all the coordinates. So if I multiply 4 by 1/2, that gives me 2. If I multiply 4 by 1/2, that gives me 2. So that's my dilation. I'm going to dilate A prime, B prime, C prime by a scale factor of 1/2, and that's going to make my triangle NOP. Okay, so now let's take a look at this second example here. If I'm given triangle ABC, and I know that it's similar to triangle DEF, again, I need to describe a sequence of a rigid motion followed by a dilation with center 0, 0. So I'm going to be dilating from this point. So let's notice again the way these triangles are named. I have ABC, and that maps to DEF. So A corresponds to D, B corresponds to E, and C corresponds to F. So again, it looks like a translation. I'm taking this triangle, see my red points are still on top, my green points are still on the side, and the blue points are on the bottom. So that lets me know I need to slide or translate this triangle. But what I need to do to translate it is I need to figure out where to translate it so that when I dilate it, it matches up exactly with this triangle. And that's the tricky part. So let me show you a trick that we found in class today. Remember that since my point of dilation is 0, 0, this is my center that I'm dilating from, if I extend a ray from this point through each of my vertices, then that's going to show me where my triangle should line up. Okay, so what that means is as I move these points, as I move point A, I'm going to translate or slide this triangle left until point A lands on this line here. So I might hope to be a little more precise. There, that maybe looks a little better. Let's try to even this out. So what I'm going to find, if I can get my lines even here. Sorry, this is kind of tedious. So what I'm going to find is that I actually need to translate this triangle over 1, 2, 3 units so that A prime lands here. And if I translate okay, I apologize for that quick little interruption. Okay, let me clean this up again and kind of show you. Kind of got a little. Okay, so basically we're trying to use these rays from the origin, since that's our center of dilation, to help us figure out how much to translate. Okay, but as we slide these points over, we're also going to have to move them down, because if you notice point B, I want that to eventually translate to point E, right? So I'm going to translate left and down. So let's go ahead and move down one, and let's come over here, and if we translate 3 units, that's going to put A prime right here at this red dot. Okay, now from B, I'm going to translate down 1 and left 1, 2, 3. That's going to put B prime at this dot. And C is going to translate down 1 and left 1, 2, 3. And that's going to put it here. So if we connect these, then we have translated the triangle here. And now to dilate it, if I dilate this blue triangle, I want to expand it so that this point lands here, this point lands here, and this point lands here. So to do that, I'm going to list my coordinates like we did last time and identify the scale factor. So let's record what we've done so far. So we translated down 1 unit and left 3 units. Now I'm going to dilate using a scale factor of, and that's what we're going to find out. So I'm trying to take this point here, which is B prime, and these coordinates are -1, +2, and this is going to map to, oh wait, I'm sorry, that's A prime. And that's going to map to this point here, which is -2, +4. This is supposed to be red. I'm not sure why it's not. So -1, 2 maps to -2, 4. So I'm trying to decide, how do I turn a -1 into a 2 and a 2 into a 4? Knowing I have to use multiplication, it seems like I can double these. So let's see if a scale factor of 2 will work for these other points. Okay, so here is B prime. B prime is at -2, 0, and that's going to map to point E, which is at -4, 0. So can I use a scale factor of 2? -2 times 2 is -4. 0 times 2 is 0, so that works. And now let's check C prime to F. So C prime is at 0, -2. And it's going to map to point F, which is at 0, -4. So if I multiply each of these coordinates by 2, that gives me these new coordinates, so my scale factor is 2. Okay, let's skip down and let me show you part 2. So we can also do the same thing with rectangles. So A, B, C, D, and E, F, G, H are rectangles, and we see that they're similar. So A corresponds to E, and B corresponds to F, C corresponds to G, and D corresponds to H. So what we notice this time, and the reason the order matters, is because it shows us that this time I'm not translating, because purple was on the top right and now it's on the top left. Red was on the top here and now it's on the top right. So what we've actually done is we have taken this rectangle and we've reflected it across this line. And this line is at x equals 1. So rectangle ABCD is 1 unit away from this line of reflection, and let's see, EFGH is 1 unit away. That's how I know that this is my line of reflection. So what I need to do now, my first step is to reflect across. The line x equals 1, and now I'm ready to dilate. So let me pause the video and draw this reflected rectangle for us. Okay, so I've reflected this rectangle. So this point up here, let's try this again. This will be A prime, D prime, B prime,